particles of matter attract each other. First property is particles of matter have spaces between them. Second property, they are continuously moving. Third one is particles of matter attracts each other. Okay, if we consider solids are they are very attractive. They are very attractive because of force of attraction between the particles. We know no, solids are stronger when compared to liquids, compared to gaseous. Here, solids are more strong. Solids are more stronger. Why? Because of force of attraction between the particles of matter. Particles of matter. Okay. So there are some force of attraction between the particles of matter which bind them together. Why we say that if two friends are there, they're very strongly bonded with each other. They are two friends, they are strongly bonded with each other. So no one can break the friendship by saying something or doing some different activity. They can't break the thing. Why? Because they are having strong bond. They are strong bond. Understood? Like that, solids are having more force of attraction when compared to liquids and gases. That force is nothing but coercive force. What is that force called? Coercive force. The force of attraction between the particles of different substance is called adhesive force or coercive force. They are very strongly bonded with each other. So one common example I can say that in a classroom, the teacher divided the children into three different groups. In a classroom, the teacher divided the children into three different groups. Okay, one group consists of, each group consists of 6 children in that particular group. Okay, 6 one group, that is group A, and one more group is group B, consists of 6 children, and the group 3 also consists of 6 children in that particular group. Okay, what the teacher said? The teacher said the first group children to hold their hands with the help of just touching their tip like this. Like one child, one fingertip touched to the other child fingertip. Like that, all the 6 children stood in one particular line by just touching the fingers. By simple touch, they just hold each other and they stood in one particular straight line or one curved line. Understood? Are you getting it? Are you getting? And the second group, children, they are also like how many members of children present in the second group? Like same number, like 6. Okay, their strengths are same. They divided evenly, homogeneously. Like they are not divided into one is strong group and other one is weak group. The way they are holding is different. Understood? First group, they just hold it like this. I think it's visible now, how I am showing. Okay, they hold it. One child's just tip of one child's finger and the other child like that in a straight line or in a curved line. The second group, the child just hold. They just lock their hands like this in the second group. And in the third group, children, they just hold it from their back like this strongly. Like one hand, like hold it from the back and they're strongly hold it so that they are very close when compared to first group, second group and the third group. Understood, children? Understood? All the children are having same strength. They are homogeneously evenly divided into 3 groups. Only the arrangement, only the holding is different from first group to the second group to the third group. And the third group, from the back, they hold it like this. They're just locked from the back so that they are very tightly packed when compared to first, second, and third. And one child, the teacher allowed the other child to go and break the bonds of hands from first group to the first group, second group, and the third group. So the child went to the first group. He just break the bond, like they just tip so easily. The chain broken. Understood? Have you just imagine the thing what I'm explaining, children? So in the next session, if you want, I just show you a nice video of the particles of matter attract each other. And second group, when compared to first group, the child requires some energy to break the link bond to the children within the children, because they are holding like this now. So he requires some energy to break. And the third group, what he has done? They are very tightly packed. They are interlocked like this from the back. So he requires much energy to break. So he can't break it. What did you observe? What did you understand by this, children? What did you understand? All the three are solids. All the three groups are solids. Consider the children are nothing but particles. Few particles are loosely packed. Some are compared to, all the three are solids now. And the other one is a little bit tough when compared to the first one. And the third group is very strong because the particles are the children are very strongly bonded. They attracted, they hold their hands very strongly so that the breaking is very difficult. So all the three are solids. Or each child is considered as particle. The holding is nothing but what? Bonding or binding with each other. So with this, all the three groups, we can simply say that the particles, though the solids are the force of attraction between the solids are very strong, but it depends upon the arrangement of the particles and the force of attraction between the particles.